Dear students, in today's class, we discuss chi-square distribution for the test of goodness of fit. This test basically compares the observed frequency with the experimented frequency or the data, whether the observed data is in line with the experiment data or not. Let's see the test first. If O1, O2, O3 up to ON be a set of observed or experimental frequencies, and the set of corresponding expected theoretical frequencies be E1, E2, E3 up to En according to a certain theory, then chi-square is defined as chi-square is equal to O1 minus E1 the whole square by E1 plus O2 minus E2 the whole square by E2, so on up to n terms, which we can write in summation form as summation of OI minus EI the whole square divided by EI with n minus 1 degree of freedom. Here, summation of OI and summation of EI both are equal to n, which represents the sum of the frequencies. Now, let's see the problem, how to solve the problems in this category. The first problem says, in an experiment on pea breeding, the following frequencies of seeds were obtained. Theory predicts that frequencies should be in proportion 9 is to 3 is to 3 is to 1. Examine the correspondence between theory and experiment. Given that chi-square of 5% with 3 degree of freedom is 7.81. The data given is rounded and yellow seeds are 315 in number, wrinkled and yellow are 101, rounded and green 108, wrinkled and green 32 seeds. So altogether we have 556. So let's see how to verify this, whether the theoretical and experimental data is same or not. Here the total number of seeds are 556. Theoretically, the seeds are in the proportion 9 is to 3 is to 3 is to 1. So let's find out of 556, what are the number of seeds of each type. For this, uh, the total number of rounded and yellow seeds will be 9 by 16 of 556, which will be approximately 313. We need to round off the numbers to the nearest integer. We represent this by E1. Similarly, we can find out the wrinkled and yellow seeds, which is third part of the total proportion. So 3 by 16 of 556, we get 104. We denote it by E2. Then rounded and green are 3 by 16 again of 556, which will give us again 104, denoted by E3. And finally, wrinkled and green is 1 by 16, one part of the total. So 1 by 16 of 556, which is 35, denoted by E4. Now we construct this table of observed frequencies and experiment theoretical frequencies. And we find out what is O minus E, the whole square divided by E. So the different values of O and E are listed here. Like the first one is O observed frequency is 315, experiment frequency is 313. If you plug these values in this formula, we get 0.0128. Repeat the same procedure for the other set of frequencies and then finally add all the values in on the last column. So we get summation of O minus E the whole square divided by E as 0.5102. Now this summation is nothing but chi-square. So we got the value of chi-square as 0.1502. But it is given in the problem that chi-square at 5% is 7.81. So chi-square what we calculated is less than chi-square at 5%. It means the hypothesis is accepted, or we can say the theoretical and experimental data is matched. Hope you have understood this problem. Let's see another problem on this to understand the concept better. A set of 5 similar coins is tossed 320 times, and the results are listed below. They test the hypothesis that the data follows binomial distribution. It is given that chi-square at 5% with 5 degree of freedom is 11.07. The data given is number of hits 0, 1, 2, 3, 4, 5, and number of times is 6, 27, 72, 112, 71, and 32. So we need to verify whether this observed data is tallying or it follows binomial distribution or not. For this, we use the formula for binomial frequency distribution, that f of x is equal to n times p of x is equal to x. For binomial distribution, the formula for p of x is equal to x is ncx p to the power x q to the power n minus x, where small p and small q represents the probability of success and probability of failure. In this case, probability of success is getting number of hits, and probability of failure represents uh, number of not hits. Here, the data given is the number of hits they have given and number of times they have repeated the experiment. Let's substitute the capital N number of times the coin is tossed is 320, and there are 5 coins, so the small n value is 5. When we toss a coin, the probability of getting head is half, is zero point 0.5, and not getting half is also zero point 0.5. We denote these values by. Now let's construct the table. Observed frequencies are already given in the problem. For experimental or theoretical frequencies, we need to substitute x is equal to 0, 1, 2, 3, 4, and 5. The corresponding values of f of x or e, we get it as 10, 50, 100, 100, 50, and 10. Once we get the experimental frequencies, sorry, the theoretical frequency, we need to substitute observed and theoretical frequencies in the formula O minus e the whole square divided by e. For different set of values of O and E, we get O minus E the whole square by E as 1.6, 10.58, 7.84, 1.44, 8.82, and 48.4. Summing it all the values, we get summation of O minus E the whole square divided by E as 78.86. This is nothing but chi-square value. But chi-square at 5% is given in the problem as 11.07. So we conclude that chi-square, what we calculated, is greater than chi-square at 5%. Hence, the given data does not follow binomial distribution. Hope you understood the concept of chi-square test well. Thank you.